Now, to finish the strong titration, we need to remember just a few things, simple things. The first is that molarity is always equal to moles over liters. That's our concentration. The next thing we need to remember is that for a strong acid, concentration of H plus is always just equal to the concentration of the acid itself. So the concentration of H plus in hydrochloric acid is just the concentration of the hydrochloric acid. Remember, it's a large K, so it's a big X problem and a small Y problem. And the same is true for a strong base. The hydroxide is equal to the concentration of the base. The last thing we need to remember is that pH is the negative log of the concentration of hydronium, which means that for a strong acid, that's also just equal to the negative log of the concentration of the acid itself. So we're going to use those ideas and finish up the table. So here's the table that we had before with all the work that we've done in the other video. So now we just need to figure this out. Our goal again is to find the pH. That's what we're asked for at each of these steps. So we remember that pH is the negative log of the concentration of the acid at this point, which is HCl. And concentration is moles per liter. What I have here is moles. What I have here is volume, although it's in milliliters, not liters. So this is really going to be equal to the negative log of the moles that I have, 0.0150, over the liters, which when I work that is 0.100 liters. That's all I need to do. So I grab a calculator, and if I do that work, the negative log of 0.015 divided by 0.1, and that works out to be 0.824. So, finishing up the rest of this table is pretty much the same sort of work. Again, I've got acid here, so the pH is going to work out to be the negative log of this value, 0.0147, over this converted to liters, 0.101, which works out to be 0.837. Same process here. pH is negative log of moles that I have, 0.0120, over liters, 0.110, works out to be 0.962. Same process here. pH, negative log, 0.0006 over 0.148 is 2.39. Here I've got an issue. And the issue is that I don't have anything to take the log of. But if we recall, what this means is that I have no excess acid, I have no excess base, so what I really have is just salt water. pH is 7. No math to do, no work to justify it. If you have a strong acid and a strong base, at the equivalence point, the pH is 7. Now, it looks like I could set up the same sort of thing here. I can take the negative log, take the moles, 0.00006 over 0.152. The problem is that this is not acid, which means when I do that math, I will not be finding the pH. I'll be finding the pOH. I do that work, it turns out to be 2.40. To get the pH, I need to take 14 minus pOH. It works out to be 11.60. Same process here. I got excess base, so the pOH is going to be the negative log of 0.0075 divided by 0.175, works out to be 1.37. pH therefore is going to be 12.63 when I subtract that from 14.